Hello class, welcome everyone to today's class. This is the second lecture in the series of the online lectures that we shall be having, and the course code is COS 101, and the course title is Introduction to Computing Science. In our last lecture, we discussed a lot of things, and where we stopped was on classification of computers, where we said that computer systems are classified under four major headings or topic. We have classification of computer by type, classification of computer by size, classification of computer by purpose, and classification of computer by generation. So today we are going to start with classification of computer by generation, after which we shall now go into classification of computer by purpose. In fact, for today's lesson, I have created the lecture outlined. Okay, so the first thing we shall consider today is classification of computers by generation. It is shown there on the screen. Classification of computer by purpose, hardware and software. Then under hardware, we shall consider functional component of computer system. We shall talk about input unit, processing unit, output unit, storage unit. Then under hardware, under software, we look at types of software, classification of software, and kinds of software. So today we begin by letting us know about classification of computers by generation. Under here we have generation of computers. Computer system is divided into generation. Computer system is divided into generation. This generation tells us about the technology that was used in building these computer systems. Computer system did not just happen. It passed through phases of evolution. Okay, so this generation tries to tell us the technological component that make up each of these phases of computer systems. Okay, so we talk about the first generation computers, which are computers that were created between 1940 to 1955. We shall look at the characteristics of each of the generation later on. But for now, I'm trying to highlight the generation of computers. So there are 5 generations of computers. We have the first generation, which was computer system that were created between 1940 and 1955. We have second generation computers. These were computers that were created between 1956 to 1963. We have third generation computers that were created between 1964 and 1971. We have the full generation computers that emerged from 1971 to the present because it overlaps with the fifth generation. So the fifth generation is the computer system we are presently having now and the one that are yet to come. So these are the division of computers into various generations. We have 5 generations as shown on the screen. So let us look at the characteristics of each of these generation of computers. So first of all, we shall start with the first generation computers. Okay. Remember that first generation computers came out in the 40s and spans into early 1940s and span into 1955. Now, what you should know about first generation computer is this. Number one, they use vacuum tubes for circuitry and magnetic drums for memory. Okay, they use vacuum tubes. So vacuum tubes were a special kind of tube that we use in building the circuitry of the first generation computers. Okay, vacuum tubes were very bulky, they were big in size, and that basically accounted for the large size of first generation computers. Okay, so magnetic drums we use for memory. Now, number two characteristics is that they were often enormous in size, taking up entire room. That means that first generation computers were very big because of the technological components that were used in building these types of computer system. Vacuum tubes were bulky, they were big, and this invariably accounted for the large size of the first generation computer. So a first generation computer can take up an entire room. Okay, it can be as big as a transformer. Okay, and it was always placed in the room. Okay, and now number 3 point is that they used to consume a great deal of electricity. They used to consume a great deal of electricity. That means that for you to be able to use first generation computers, then you need to have a power source that will be able to supply a great deal of electricity to this computer system. Okay. Number 4, they consume a lot of heat. Okay, which was often the cause of malfunction. They generated a lot of heat, which was often the cause of malfunction. Okay, now because of the heat it used to generate, this heat used to disturb some component of the computer system, causing it to malfunction. That was why in those days, first generation computers were put in a big room with air conditioning system, okay, supplied to them, okay, so that the AC can absorb the heat generated by the computer system. Okay, so they were not reliable. They used to malfunction a lot. Okay, because of the heat it generates. This heat would make some component of the computer system not to work properly, making the computer system to malfunction. Now, number 5 points you should know also is that this generation of computer relied on machine language. Okay, machine language is the lowest level language understood by the computer system. Okay, for some of us who have done computer courses somewhere, you agree with me that there are two major levels of programming languages. You have the low level programming language and you have the high level programming language. So the first generation computers relied on machine language, okay, which is the lowest level language understood by the computers. Machine language is a language where instructions are given to the computer system uses series of zeros and one. That is what the computer system understands basically. The computer system understands information that is given to it in binary format. Okay, so the first generation computers relied on machine language, which was basically language where instructions was given to the computer system using strings of binary code. Okay, number 6 points you need to understand about first generation computers is that input was based on punch cards and paper tape, okay, and output was displayed on printout. That means that when you want to feed in input data into a first generation computer, then you need to punch those input on a card. So the name of that card was punch card. If you want to represent maybe digit 5, there's a way the digit will punch on the card, and now that card will now be fed into the computer system, and the computer system will now extract the code on that card representing 5. Okay, so the output was only on printout. There was no visual display units. There was no way output could be displayed on the screen, because technology at that time, okay, did not permit the visual display unit to be incorporated, okay, with the first generation computers. Okay, so these are the things you should know about the first generation computers. Example of first generation computers include ENIAC. ENIAC stands for Electronic Numerical Integrator and Calculator. In fact, it was one of the earliest, okay, first generation computer system. Okay, it was the first can I say digital computer system. Okay, ENIAC. Now the second one is the Electronic Delay Storage Automatic Computer, EDSAC. Is that on the screen? Okay, now this computer was developed in the UK, okay, and became operational in 1949. This was one of the first practical stored program computers. Okay, now we had EDSAC, Electronic Discrete Variable Automatic Computer. Okay, Electronic Discrete Variable Automatic Computer. Now another one is UNIVAC, which is a universal automatic computer. So these are few examples, okay, of first generation computers that you need to understand. So we have now gone through the characteristics of first generation computers. Okay, remember this computer emerged, started coming out in 1940 started coming out in 1940 and went up to 1955. So that is that on first generation computers. So one thing you should know about first generation computer is that they use vacuum tubes for their circuitry and magnetic drums for memory. They were often enormous in size, taking up entire room. They consumed a great deal of electricity. They generated a lot of heat, which was often the cause of malfunction. So the other point, you also need to take note of the other point. Okay, so we are now going to consider second generation computers. Okay, we are now going to consider second generation computers. Okay, is there on the screen? So second generation computers. Now the technological component of the second generation computer vary greatly from that of first generation. Okay, now what you should take note that transistors replace vacuum tubes as the important circuitry components, okay, of the second generation computers. Okay, that means that transistors replace vacuum tubes and ushered in the second generation of computers. Okay, so transistors were superior to vacuum tubes, okay, allowing computers to be smaller, faster, cheaper, and more energy efficient than the first generation computers. That means that the first generation computers were very big and could take up a space that could be given for a room. Okay, but when the second generation computer came out with transistors, computer system become much smaller than the first generation computers, and they were faster, cheaper, and more energy efficient. That means that they did not consume much energy as compared to the first generation computers. Okay, second generation computers were more reliable than the first generation computers. They were more reliable in the sense that they were not prone to malfunctioning. They were not prone to malfunctioning because they did not use to generate much heat. Okay, they were not prone to malfunctioning, so they were much more reliable compared to the first generation computers. Now, there's one similarity, okay, between first generation and second generation. That similarity is that the second generation still relied upon punch cards and print out for output. That means that data and information in this were still given to the computer system via punch card, through punch card. Okay, punch card is a special input device that we used in giving instructions and data to the computer system in those days. Now, using punch card, information has to be perforated on the card. Information has to be punched on the card. Okay. Now, every information you punch on the card represents the code that when the computer system reads from that card, it will actually understand what letter or what data that could represent. Okay. So, punch card was still being used in the second generation computers, and print out was still on the output rather was still on print out. Now, the next characteristic is that the second generation computers use symbolic or assembly language, okay, which allowed programmers to specify instruction in words. That means that there was a great deviation. While the first generation computer system relied on machine language, the second generation computers moved slightly away from that, and they made use of assembly language. Okay, though assembly language is still a low-level language, but it's easier to program using assembly language than using machine language, because in machine language you can easily make mistakes. Okay, every character, okay, must be represented as a binary string. Every letter must be represented as a binary string. Okay, so everything was represented in binary. So if you make mistake in one binary character, that means that you're providing the system with a wrong instruction or a wrong data. The assembly language was much easier to use, and which allowed programmers to specify instructions, okay, in words. Okay, that means that instead of using code, they were instead of using binary code, they were mnemonic codes. We call them mnemonic codes that we used to represent every instructions, okay, that was given to the computer system. Another characteristic is that instruction was stored in memory, okay, which moved from magnetic drum to magnetic core technology. Okay, so example of second generation computers include IBM 7000 series. So IBM 7000 series, you can find out the meaning of IBM. IBM stands for International Business Machine. We have IBM 1790 series. We have CDC 164. We have Atlas. So these are few examples of second generation computers. Now let us look at third generation computers. These are computers that were seen between 1964 and 1971. Okay. Now, what was the major technological component of third generation computers? What was the major technological component of third generation computers? Now look at this. Now, the development of integrated circuit was the hallmark of third generation computers. The development of integrated circuit was the hallmark of third generation computers. What does it mean? What it means is that integrated circuit marked the major technological component of third generation computers. That means that the circuit were made up of IC. Okay, so we call it integrated circuit. Now this IC was invented, okay, in 1958 by Jack Kilby. Okay, in fact, Jack Kilby invented the concept of IC in 1958, and the first IC was invented and used in 1961. The first IC was invented and used in 1961. Okay. So a single IC may contain thousands of transistors mounted on a silicon chip. That means that a single IC contains thousands of transistors compressed together and mounted on a silicon chip. Because of the advent of IC, okay, the third generation computers, okay, become much more smaller in size, faster and more reliable and less expensive. Okay, because the transistors were compressed. Okay, thousands of transistors were compressed and put together on a silicon chip. Okay, because of this structure, okay, the computer system in the third generation computers became much smaller in size, and they were faster and much more reliable and less expensive. One other thing you should know about third generation computers is that computers in this generation started making use of keyboard for input instead of punch cards. Okay, remember that in first generation, second generation, we had to rely on the punch cards, okay, for input and printout for output. But in third generation computer system started making use of keyboard to enter data and programs, okay, and the monitors we use for output, and monitors we use for output. So it now becomes very easy to enter your data through the keyboard, and for you to see what you have entered come out on the monitor, and also the result of processing your data too, okay, can also be shown on the monitor. Some people call it monitor, some people call it screen, okay, but it's a display unit. The technical name for monitor is visual display unit, where the output from the computer system is shown on the screen. Okay. Another characteristic is that we started having operating system. Okay, operating system was invented during this period of time. Okay, and that made computer system to start running many different applications at the same time. Okay, remember that operating system is a system program that manages the running and execution of application programs. Okay, so with third generation computer system, we started having operating system. Okay, operating system started coming out, and this made computer system to run different applications at the same time. Okay, examples of third generation computers include IBM 360 series, CDC 6600, ICL 1900. Okay, these are few examples of third generation computer. After third generation computers, we now have fourth generation computers. Remember, we have first, second, third, and fourth. Please, you have to take note of the year range that this computer system emerged, and you also need to take note of the technological components of this computer system. Then you have to take note of the features this computer system had. Okay, so at least this point would be considered important, okay, when you are trying to talk about generation of computers. We are now at fourth generation computer. We want to look at the characteristics of fourth generation computer. Number one thing you should know about fourth generation computers is that microprocessor became the major component, okay, of a fourth generation computer. Microprocessor, okay, became a major circuitry component of fourth generation computers. Microprocessor, okay. Some people will call it processor. Some people would refer to it as microprocessor. So a microprocessor contains thousands of IC, that integrated circuit, built onto a single silicon chip. Okay. So microprocessor, remember, is important in the computer system because that is where we consider as the brain of the computer system. Okay, so all program instruction execution, okay, all forms of arithmetic operations, logical operations, all of them, okay, take place in the microprocessor. So the microprocessor handles all of this. Okay, so microprocessor brought in the fourth generation of computers. Now, microprocessor contained thousands of integrated circuits built onto a single silicon chip. The first microprocessor was the Intel 4004 chip, developed in 1971. The first microprocessor was the Intel 4004 chip, developed in 1971. Okay. This computer system, because of the presence of microprocessor, have fast processing power with less power consumption, that is energy consumption. Okay, they have fast processing power with less power consumption. Okay, computers in the fourth generation were generally, okay, general purpose in scope. Okay, they were general purpose in scope, in the sense that you can use them for entertainment. You can use it for business purpose. You can use it for scientific purpose. You can use it for gaming. can use it for a whole lot of other things. Okay, so they were general purpose in scope. Now, because of the microprocessor, computer became very small, very small. So what in the first generation computers filled an entire room now fit in the palm of the hand. That means that we started having laptop computer systems because of the advent of microprocessor. We started having we call them laptop, some people call it briefcase. We have palm top, okay. We have desktop system. So all these are small computer systems, okay, because microprocessor made it possible for the size of the computer to be further reduced into a size that can put on our laps, or that we can handle with our palm. Okay, computer system became more powerful and could be linked together to form networks, which eventually led to internet. Okay, microprocessor brought in the development of PC, personal computer system. Okay, these personal computer systems were everywhere, and because of how powerful these personal computer systems were, it was possible to link all of them together. Okay, computers in a particular location, it was possible to link them together for them to share information, okay, files and other resources. And this, linking of computer system and allowing them to form network eventually led to the advent of the internet. Okay, there is a module in this course that we are going to study, and it's talked about internet. So we shall wait until we get there. When we get there, we talk more about internet. Okay, so but what you know is that the fourth generation computer brought in personal computer system. Okay, which is a small computer system that have the capability of being linked together to share information, files, and other resources. Another point about fourth generation computer is that it supports high-level programming languages. I remember I made mention of levels of programming languages, where I mentioned that we have low-level programming language and high-level programming language. So the low-level programming language were actually peculiar with the first generation computer system and the second generation computer system. The third generation computer system, we started seeing some high-level languages, okay, coming up, like Fortran, like COBOL and the likes. Okay, but when we talk about fourth generation computer system, this computer system support all types of high-level programming languages. Okay, now for those people who are not familiar with the high-level languages are those programming languages that are closer to the human programmers, okay, than the machine itself. Okay, that means that instructions can be written using English-like words to the computer system. Okay, so it has a well-developed logic that allows the computer system to allows the programmers rather to concentrate on developing robust program instead of looking at the underlying details of how the program runs. Okay, so the high-level languages, okay, are languages that are closer to us, the programmers. Okay, and we can actually use this language to write programs for the computer system. But for the computer system to understand what we write in high-level languages, there must be a translator to translate the program in high-level language into the low-level language. Okay, so we are back. The screen went blank. Sorry for that. So we said that high-level languages allows a programmer to write a program, okay, in a syntax that he understands, but the computer system does not understand that syntax. So there must be a way of translating what is written in high-level languages into low-level languages to a low-level language version for the computer system to understand. Okay, it is in the fourth generation computer that we also have seen the emergence of LSI and VLSI circuit. Okay, LSI stands for large scale integrated circuit or large scale integration, and the VLSI stands for very large scale integration. Okay, so SI stands for large scale integration and VLSI stands for very large scale integration. So these types of circuit, okay, we designed and developed during fourth generation computers. Okay, example of fourth generation computers include Apple Macintosh, okay, IBM PC, Star 1000, etc. So these are the few examples of fourth generation computers. Let us quickly go to fifth generation computers. Fifth generation computers are computers that we are currently seeing and the ones that are yet to come. So the computer system that we currently have now and those ones that are yet to come are classified under fifth generation computers. What are the things that make this type of computer system different from the earlier ones? Okay, now number one, fifth generation computers are based on artificial intelligence. Okay, fifth generation computers are based on what? Artificial intelligence. Artificial intelligence is a way of creating computer systems and programs that can imitate human behavior and human reasoning. Okay, that means that creating computer system to be as intelligent as human beings. Okay, so under this, the computer system, okay, are now created that can understand spoken words and imitate human reasoning. Okay, we have programs nowadays that can imitate the way we reason, that can make decisions on our behalf. Okay, that can go through the reasoning process that human beings apply in coming out with a solution to a problem. Okay, so this is all part of artificial intelligence. So fifth generation computers are computers that are marked by the introduction of what? Artificial intelligence into them. Another point is that these computers can respond to surroundings using different types of sensors. Okay, that means that computer system in the fifth generation can sense environment, okay, and behave appropriately or give out appropriate response depending on the inputs it gets from its environment, okay, using sensors. Okay, so that is the reason now you can have a system that can dictate that there will be fire outbreak in a house, okay, in a building, because there are sensors that taps in information in the environment and feed it to the computer system for analysis. From there, the computer system will be able to predict that there might be fire in this building because the amount of fumes it dictates is more than the ordinary amount of fumes and stuff like that. Okay, so these types of computer system make use of artificial intelligence. Computer system in the fifth generation all have parallel processing capability. That means that it is possible for them to have 2 or 3 processors or even more than that, okay, working together in parallel, okay, to carry out data processing activities, okay. So that means that in a computer system you can have processor 1, processor 2, processor 3, processor 4. Then using the technique of parallel processing, all these processors can work together parallel to carry out complex data processing activities, okay, which can even include data mining, okay, operations. If I want you to know about 5th generation computer is that the goal of 5th generation computer is to develop devices that respond to natural language input and are capable of learning and self-organization, okay. The goal of 5th generation computing is to develop devices that responds to natural language input and are capable of learning and self-organization. Okay, so this is what we have concerning generation of computers, okay, starting from the first, the second, the third, the fourth, and the fifth with their characteristics, okay. I hope for your attention. We are going to go to the next subtopic now, which is classification of computers by purpose. Classification of computers by purpose, okay. When we are talking about classification of computers by purpose, we are looking at describing how versatile a computer system is, okay, when they are used in data processing, okay, how versatile the computer system is. So classification of computer by purpose is based on how versatile computer systems are in data processing. Under this classification, okay, under this classification by purpose, we have 2 types of computers. We have special purpose computers and general purpose computer systems, okay. I'm going to give you a rundown of the characteristics and example of special purpose computers. Then after that we go to general purpose computers. Now let's take a look at special purpose computers. Number 1, these are computers built for a specific application, okay. They are built for a specific application. They are designed to solve a specific problem and not applied to any other computational activities, okay. So these computer systems are built to handle a specific job. They are built to handle a specific task. They are task specific computer systems, okay. That means that they have been built and fine-tuned to handle that task, okay, efficiently, okay, from the word go, okay, to the end. So it handles only one type of activity, solves only one kind of problems, okay. The programs of instructions, okay, is built into or stored permanently in the machine. That means that the programs of instruction used by special purpose computer systems, okay, are hardwired or built permanently and stored in the machine, okay, built and stored permanently in the machine. What am I trying to say? This kind of computer system come with hardwired programs. You cannot install additional programs on them, okay. So the programs they come with are programs that determines the functionality of the system. Okay, you cannot install any other program on it. You cannot bring another program into it. No. So the program it carries are the programs that were stored by the manufacturers of the system. Okay, so there's no way you'll be able to tinker with that program because it is hard coded, because it is hardwired into the memory of that machine. Okay. Special purpose computers have the capability of performing only one task, like I have said earlier on. As such, they are referred to as dedicated machines. Okay, they are referred to as dedicated because of their limitation to specific task at hand. Okay, they have the capability of performing only one task. They are referred to as dedicated because of their limitation to handle specific task at hand. Now you might be wondering, what are the examples of this type of machine? I'll give you two clear examples, okay, that you are familiar with, even though you might not really take notice of. Now the first one are the ATM machines we have. Are the ATM machines, okay? Now ATMs are machines that are programmed solely for banking tasks, like dispensing cash and processing deposits. Okay, so ATM machines are special purpose computers. You cannot go to an ATM machine because it has a keyboard and you say you want to type your Word document and print it out. No, it will not be. You will not be able to do that because ATM were not designed. Okay, ATM were not designed for those kind of activity. Okay, so ATM stands for automated teller machines. For some of us who may not know the meaning of ATM, ATM stands for automated teller machines. So these ATMs are programmed solely for banking tasks like dispensing cash and processing deposits. Okay, so that is what they do. They don't do anything more than that. Okay, their own is to handle cash. Now another one that we are all familiar with is what we call POS. POS, we call it point of sale, okay, device. POS, we have it, well, in Nigeria here, we have it almost everywhere. Around the corner there at the end of the street you have it. Basically POS POS machines are used in supermarkets, they are used in shops, they are used in where you go to buy things. If you don't have money with you, you can use your ATM card to do payment using POS machine. Okay, in Nigeria here we use POS to withdraw money. Okay, if you need money, you can go there, you give your ATM card, you put it inside POS machine, you punch in the amount of money you need, then there will be debit operation. Okay, the money you've typed in will be transferred into the POS account, and the person there in charge of the POS machine will give you the money equivalent and the note itself. You can take it and do what you want to do with it. Another example of special purpose computers are specialized computers used in MRI scanners, okay, CT scanners or ultra machines designed for specific image analysis. Okay, and these are all medical terms. Thank God we are in the allied health institution, so some of you people will come across these terms in other courses. As you go higher, you'll be seeing some of these terms. Okay, so these are special scanners that are used to scan organs, okay, in the body system, or used to get images, okay, of or a cross section of the internal organ of the body for analysis, okay, and stuff like that. The ultrasound machine, well, is designed for, I know these ones are normally used in antenatal care to track the heartbeat of a fetus in the womb. Okay, so these are all special purpose computer systems. Remember, they are built for a specific application. They are designed to solve specific problem and not applied to other computational activities. Then one other one that just came to my mind now is the meter we have in the fuel pump for those people who go to buy fuel at filling stations. Okay, you discover that when you want to buy fuel, the attendants will punch in either the quantity you want to buy or the amount of fuel, okay, in terms of the worth of it. Okay, you punch it in, then you will press enter key. Then before you know it, the computer system will start dispensing fuel into your vehicle or into your gallon. So this is another example of a special purpose computer. Okay, it is only for specific purpose, to measure the amount of fuel that is being dispensed, okay, in terms of the money value or in terms of the liters quantity that is being dispensed. Okay, so that is that. Now let's look at the other one, which is the general purpose computers. Okay, general purpose computers. We just finished with special purpose computers, so we are now looking at general purpose computers. These machines have the capability of dealing with variety of problems. General purpose computers are computer system that can handle variety of problems. Okay, they are not built to handle a specific task. They are not built to solve a specific problem. They can handle a variety of problems. Okay, now why is it possible, okay, that they can handle this variety of problems? Because it's possible because they store different programs of instructions that can perform different type of task. Okay, they can store different programs of instruction that can perform different type of task or operation. Okay, that's what we call general purpose. Now let me give you an example of a general purpose system. Our computer systems, our digital computer system, our laptops, our desktop system are classified as general purpose computers. You know why? Because that computer system can be used in preparing, in generating our electricity bill. That computer system can be used by an engineer or an architect in developing his structural or building plan or engineering plan. That same system can also be used by a musician in recording and editing his song. That same computer system can be used by a graphic artist, okay, and in developing different type of graphics, okay, different type of designs for his kind of job. Okay, so these examples will show us that general purpose computer system can handle variety of different tasks. Okay, so you can use it to process business data, okay, and they can also be used to process complex mathematical formulas. Okay, so please take note of this point I am raising in this lecture. Okay, let me give you a rundown of the point now. General purpose computers. These machines have the capability of dealing with variety of different problems. They act in response to variety of programs created to meet different needs. 3, They can store different programs of instructions and thus perform a variety of operations. 4. General purpose computers can process business data readily as they process complex mathematical formulas. Most digital computers are general purpose in nature. Most digital computers are general purpose in nature. That means that they are general purpose computers in nature. So that is that concerning classification of computer by purpose. Okay, now let's go into another topic. We are going to consider hardware and software. Okay, we look at hardware and software. We have not really taken time to expatiate on this. So this is an opportunity for us to do that, because a lot of people might find it confusing, okay, to differentiate between hardware and software. So what do you think hardware is? Now, hardware refers to the physical unit or component which make up the computer configuration. Okay, hardware refers to the physical unit or component which make up the computer configuration. Okay, in those days when I was growing up and I was learning some concept about computer system. Okay, for our teacher to make it easier for us to understand what hardware is, the teacher will say hardware are the physical part of the computer system that you can see and touch. Okay, I know that. Okay, but I feel that one is a little bit elementary. We have to step up to refer to hardware professionally, okay, as a physical unit or component which make up the computer configuration. All the mechanical, electromechanical and peripheral components of the computer falls under hardware. All the mechanical, electromechanical and peripheral components of the computer falls under hardware. Example include monitor, keyboard, mouse, etc., etc. Okay, so the physical part of the computer system that can be felt and touched, okay, are considered as hardware. Now let's look at software. Software refers to programs which are processed by the hardware. Software refers to programs which are processed by the hardware. Okay, somebody might ask, what is a program? Now, a program is a sequence of instructions that are carried out by the hardware to solve given problems or to perform given tasks. So, a program is a sequence of instructions, okay, that enables the computer system to solve a particular problem or to handle a particular task. That is what a program is, okay. So you discover that some people use software in programs interchangeably. It is allowed. A program is just the basic building block for the software. So that means that a software can consist of series of programs, okay. So what you know is that software refers to programs that enables a computer system to handle a specific job or to solve a particular problem. Example of software include, some of us are familiar with these examples: MS Word, Microsoft Excel, Corel Draw, etc., etc. You can keep on mentioning a whole lot of software. Remember that there are different software in different career lines, in different areas, okay, of work. In the accounting, we have different types of softwares that are used there. In healthcare, we have set of software that are specific in those areas, that could only be applied in those areas. In engineering, we have softwares, something like AutoCAD, okay. In the educational sector, we have softwares. There are different types of software, so it depends on your area of specialty or your career line, okay. Then you can learn a software that can help you to improve on your work or to build you up in your career line. Okay, now let's look at let's still continue with the hardware part. Here we are considering the functional component of a computer system. Okay, we are considering the functional component of the computer system. A digital computer system consists of 3 distinct units. Okay, 3 distinct units. These units are the input unit, the central processing unit, and the output unit. Okay, we have the input unit, the central processing unit, and the output unit. There is a diagram there on the screen showing the relationship between the input, the central processing unit, and the output unit. Okay, now on the left hand side of the screen you have the input unit. Then in the middle box there you have the CPU, and in the right hand side you have the output. Okay, now if you see the arrow moves from the input box, goes into the CPU, then the CPU have another arrow that takes data from itself to the output unit. Okay, so the inside box there, the middle box, is what we call the central processing unit. So therefore means that when data comes in through the input unit, it goes into the central processing unit for processing, then it goes out. Okay, the information goes out to the immediate environment or to the users through the output unit. If you look at the diagram there, you would discover that the CPU has 3 subunits. It has the control unit, it has the arithmetic and logic unit, we call it ALU, right, the abbreviation for it. Arithmetic and logical unit, we call it ALU, and the last one is the memory unit. Okay, let us briefly quickly look at these units, okay, separately. Now let's look at input unit. So what is input unit all about? Now this unit receives both data and program statements into the computer to enable it function properly and to be able to solve problems. Okay, so input unit is the unit through which the computer system receives data and instructions or programs. Okay, this unit basically has some devices, okay, that enable the computer system to take data from its environment. Okay, so input devices, okay, is considered to be part of input unit, okay, which feed data and programs into the computer system. Okay, so input devices can read data from a source such as magnetic disk, okay, or data can be typed directly from the keyboard, or data can be transferred from sensors, okay, that are attached to computer system, okay, and placed in the environment. Okay, so data can be gotten from these avenues into the computer system, and this data will have to be translated into electronic impulses for transfer into the CPU. Okay, so input devices read data from a source such as magnetic disk and translate that data into electronic impulses for transfer into the CPU. The meaning of CPU is central processing unit. Examples of input devices, okay, are keyboard. Most of us are familiar with keyboard. Keyboard is an input device that enables you to type in data, okay, into the computer system. Okay, the mouse is another input device. Mouse is used to select instructions and commands, okay, for execution. So mouse controls a pointing device, okay, that allows you to click on the specific instructions you want your program to execute. Then we have a scanner. Scanner is used to get pictures, okay, or capture graphics on paper and put into the computer system. We have a light pen, we have a trackball, we have microphone, we have joystick, we have digital camera, we have web camera. So all these are examples of input devices, okay. Remember that these devices falls under input unit. Okay, now let's go to central processing unit. Now central processing unit is otherwise referred to as the brain of the computer system, okay. We call it CPU, okay. It's the brain of the computer system. This is where the computer system does its thinking. This is where the computer system does its processing. This is where the computer system does analysis of data, comparison of data. Whatever activity that the computer system carries out is domiciled in the central processing unit. So CPU basically, okay, has a function of processing data sent to it from one of the various input units. Okay, that is the core function of the CPU, processing of data, and let me put and execution of instructions. Okay, so CPU processes data sent to it, and it also takes charge of executing computer instructions. Okay, now after the execution of data, okay, the result of what the CPU generates, okay, can now be sent to one or more output devices. Okay, remember that the CPU sits in the center. The input comes in to through the input unit. It goes into the central processing unit. The central processing unit does the processing of data. Then the information, which is the output, goes through the computer system through the output unit. The output goes, okay, from the CPU to the output unit. From there, we can now get our output or our result out. The processing unit or the CPU is divided into three sections or subunits. We saw it in that diagram, okay, where we had the control unit, the arithmetic logic unit, and the memory unit. Okay, so let's quickly go over the subunit of the central processing unit. Please don't forget that the central processing unit is divided into three subunits. We have the control unit, we have the arithmetic and logic unit, and we have the memory unit. Okay, let's look at the function of this subunit. Now first, let's look at the control unit. Now the control unit is just like a traffic warden, okay, on the road or on the street, okay, that controls and coordinates traffic flow at the junction. Okay, so the control unit is basically responsible for coordinating the various operations, okay, of the CPU and by extension the computer system. It coordinates all the various operations of the input and the output unit and the CPU itself. That means that control unit brings in harmonious interaction, okay, among the various units of the computer system. The control unit controls what comes into the computer system through the input unit. It coordinates the activities of the central processing unit, and it also controls and coordinates how information is passed from the CPU to the output unit. So that means that if we did not have control unit, the computer system would have been a large chaotic environment where there is no harmony, where everything goes the way it wants. And even with that, we will not even have the computer system, okay, because that will not even give us what we may even be referred to as computer system. Because if the computer system doesn't do what we want it to do, then its aim is defeated. So the control unit coordinates all the various operations of the input and output unit and the CPU. Now let's be direct concerning its functions. Number one, it directs the sequence of operations within the system. That means that the control unit directs sequence of operation within the system. And that means that when things happen in the computer system, it happens in orderly and in a sequential manner. So the sequence of operation is being controlled by the control unit, is being coordinated by the control unit, is being ordered by the control unit. Okay, so by the time data enters the input unit through one of these input devices, is a control unit that monitors the flow of that data from the control unit into the central process, from the input unit into the central processing unit. It is a control unit that takes care of directing the processing of that data using appropriate program. It's a control unit that does that. It's a control unit that determines where the results of the operation will be stored. It is the control unit that also determines which output unit or device will be responsible for getting the output from the computer system. So you now see that the control unit controls the traffic. It coordinates the various operations of the computer systems. Number two, the control unit interprets instructions and directs its execution by the CPU. Okay, so the control unit fetches instructions from the memory, interprets the instruction, and directs on how that instruction will be executed by the CPU. So you can now see that the control unit does a whole lot of things. Like I said earlier on, it's like a traffic warden. It controls and coordinates the operations of the CPU and by extension the computer system. And the last point you should know is that the control unit directs the flow of all activities in the computer system. Yes, direct the flow of all the activities. Okay, if the printer wants to get outputs from the system, it is the control unit that directs such activity. Okay, if you want to execute any program, okay, if you want to process any data, it's a control unit that determines which part of the memory, okay, the data will be stored. It's a control unit that determines which part of the memory the program will be stored and which program applies to which data. So the control unit coordinates and controls the various operations of the computer system. Now let's look at the other subunit. We call it arithmetic and logic unit, ALU. Now this unit is responsible for performing all the various arithmetic operations such as addition, subtraction, multiplication, division, and relational operations, okay, such as not equal to, greater than or equal to, and logical operation of the other one is or good. So arithmetic and logic unit, remember, is responsible for performing all types of arithmetic operation and logical operations. So addition operation is done there. In fact, all these mathematical operations, okay, you ask the computer system to do for you. It is done inside the arithmetic and logic unit of the central processing unit. Now, that is the core function of the central of the arithmetic and logic unit under central processing unit. Okay. Data flows between arithmetic logic section and internal storage section during processing. Yes, data flows back and forth. Data is transferred as needed from the storage to ALU, processed and returned to external storage. Okay, now that is about the ALU subunit of the central processing unit. Let us look at the next one, memory unit. This is otherwise known as the main memory or the primary memory. Some people call it primary memory, others call it primary storage. It's still the same thing. Okay, so memory unit is a unit. Okay, it's a circuitry because it is represented as a circuit in the computer system that stores data and instruction before, during, and after processing. It stores data and instruction before, during, and after processing. That means that the computer system needs a place where it can keep data handy, where it can keep the result of intermediate operation handy, where it can store the result of the final operation. So this is provided for by the memory unit. Okay, that means the memory unit stores intermediate and final results of processing and make it available to appropriate cutters for further processing or to users via output unit. Okay, via is through output unit. Some people may be confused about the meaning of via. Okay, so please don't be confused. Memory unit just is a circuit where the computer system keeps data it is about to process, or data it is handling during processing or after processing data, and it is where it also keeps its final result. Okay, memory unit is divided into two. We have the random access memory and the read-only memory. The first one is always called the RAM. RAM is the abbreviation for random access memory. The R from random, the A from access, and the M from memory. Then we have the read-only memory. The R from the read, the O from only, and M from memory. That gives us RAM and ROM. Okay, let me quickly go over these two memory units, okay, so that you would understand the difference between random access memory and read-only memory. Now, when we are talking about random access memory, you are looking at the working memory of the computer system. Random access memory is memory where the computer system temporarily stores data and program it is currently processing or handling. Okay, that's what we call random access memory. So your data that is shown on the screen and your programs that are running on the screen all reside in random access memory. Okay, So random access memory is not it's not a place to store your data permanently, no. So data that reside there are temporary in nature. Okay, in the event of power outage, okay, or blackout, you discover that what you have in the RAM disappears, what you have on the screen disappears, and if your system comes back on, you might not be able to recover what was on the screen. You might not be able to discover to recover them if you did not set them appropriately to a storage unit. Okay, so that is random access memory. Another name for random access memory is volatile memory. Volatile memory in the sense that what is there is just there temporarily. Okay, it has the propensity to disappear anytime in the event of power outage. So we look at read-only memory. Read-only memory is the memory that that's instructions based mostly from computer manufacturers reside. Okay, these instructions and data are read-only. That means that you can only access them, you can only see them, but you cannot alter them, you cannot change them. That is why it is called read-only memory. Okay, you cannot change anything, you cannot alter anything. You can only access it by reading it. You can't overwrite anything in read-only memory. Okay, it is basically used in storing important programs that affect the working of the computer system. This is used to store important programs and files and data that affect the proper working of the computer system. Okay, that is why it is read-only. If you are allowed access to read-only memory, to what is stored in that memory, you might unknowingly delete some code that might even affect the proper booting of your computer system. Okay, so please know that read-only memory is a memory that when NEPA takes light, what is stored in it does not disappear. I'm using NEPA here because we are in Nigeria. So whenever there is blackout, wherever there is a power outage, what is in read-only memory does not disappear. If you put your computer system back, when light comes again, then you're sure going to see those things in there still remaining intact. Okay, so please, these differences were not captured in this slide, but I believe we have been able to capture something concerning the difference between random access memory and read-only memory. Okay, now I am done with the subunit of the central processing unit. So on the screen now is output unit. So output unit is the counterpart of the input unit. Output unit is the counterpart of the input unit. Its function is to send process result to the outside world. The most familiar example of such a device is a printer. You are all familiar with a printer, okay? The monitor too, okay, is an output device, okay? So what you know is that an output unit is a unit, okay, where process data or where result of processed data are sent to users or to the outside world. Okay. Any peripheral that receives or displays output from a computer is an output device. That word peripheral, I don't know whether it is a big word here. We always use peripheral to refer to any specialized device that is attached to the computer system to perform one function or the other. Okay, so if you attach any device to the computer system, okay, that did not originally come with the computer system itself, is referred to as a peripheral device. Okay, let me give you another example. If I plug a modem now into my system, that modem becomes what? A peripheral device. If I put a mic on this system, on my system, that microphone becomes what? A peripheral device. Okay, so any peripheral device that receives or displays output from the computer is an output device. Okay, let us go and look at the examples. We look at a familiar one you all know is the monitor. Okay, so monitors are example of output devices. Another name for a monitor is VDU. That's the more technical name for a monitor. VDU, which is visual display unit. We have printers. We all know what printers are. You want to get a hard copy of your information on paper, then use printer. You have speakers for you to listen to audio data. Okay, we have plotters. Plotters are used to plot large graphs. Okay, all right. I've included there under output unit as an assignment. Please, I want everyone to do this assignment and submit. It says describe the types of monitors we have based on technology used in building them. Describe the types of monitors we have based on technology used in building them. Then explain the two major types of printers. Explain the two major types of printers. So I expect this assignment to be submitted in a week's time. That means that by next Friday, I expect the class rep for all the departments offering this course to collect their colleagues' assignment and turn it into the ICT unit. Okay, so that is that about output unit. Let's look at storage devices. Okay, storage devices are just outside the CPU. Okay, they are used to support primary memory or primary storage. One thing about primary storage is that primary storage can only store data and information while the computer system is busy, while the computer system is handling one job or the other. Okay, as soon as computer system shut down, what we have in primary memory disappears. So where do we keep our data? Where do we keep our files? Where do we keep our programs? Okay, they are not in primary storage. Please take note. They are not in primary storage. Primary storage are not used for storing of files and data for safekeeping. No, they are basically used by the CPU in handling data that are currently being processed, or the instruction that the system is currently handling. So as soon as the computer system shut down, whatever you have in the computer system on the primary storage disappears. Okay, remember that another name for primary storage is main memory or internal memory. Okay, now we have the secondary storage. Secondary storage or auxiliary storage, okay, is the second storage, okay, after primary storage. Okay, remember like I mentioned in last class, primary storage or primary memory loses data when the device is powered down. It is volatile storage. Okay, so if you want to keep your data for permanently, if you want to a place where you can store your data and you transfer it to another system or to another device, then you need to use secondary storage or auxiliary storage. Now that brings us to storage devices. So when we are looking at storage devices, we are basically referring to secondary storage or auxiliary storage. Okay, now they differ from primary memory or storage in the sense that secondary storage is not directly accessible by the CPU. No, it's not directly accessible by the CPU. The CPU can directly access data and information in the primary storage. So if your data in the secondary storage needs the attention of the CPU, that data in the secondary storage or auxiliary storage will have to be loaded. You have to be transferred from the storage unit to the primary memory. It is in the primary memory that the CPU can now access data and instruction directly. Okay, so what you have in the secondary storage, you have to be loaded to the RAM or to memory before the computer system before the CPU can access it. Secondary storage does not lose data when the device is powered down, so it is not volatile. Anything that is not volatile is otherwise called non-volatile. Okay, so secondary storage does not lose data when the device is powered down. Okay, that means that it is not volatile, whereas the primary storage, okay, is a volatile storage. One other thing you should know about secondary storage or storage devices is that it is used to store large volume of data and instructions permanently, sometimes outside the computer system. It is used to store large volume of data and instructions permanently, sometimes outside the computer system. They are slower in speed compared to primary memory. Okay, secondary storage or auxiliary storage are slower in speed compared to primary memory, and you should also know that they have higher storage capacity compared to the primary memory. Okay, so what are we looking at? We are looking at storage devices. Okay, and storage devices are basically referred to as secondary storage or auxiliary storage. Okay, you have the primary storage, which we have discussed before. Now we are looking at secondary storage or auxiliary storage. Okay, now example of storage devices. Okay, storage devices which are otherwise called secondary storage or auxiliary storage include optical storage devices such as CD. CD is what we call compact disc. We have DVD, digital video disc. We have Blu-ray. Okay, we are all used to CD and DVD. Okay, these are optical storage devices. They are circular in nature, flat plates and circular in nature. Okay, and most songs come in CDs and DVDs. Okay, in those days CD was basically for audio recording, and now we have DVD that you can also record videos and audio songs. And we have hard disk as an example. Hard disk is a fixed disk. It resides inside the computer system. You cannot remove it unless you want to open your computer system and change it, but you can't do it by yourself. You need to have the services of the technical people who will do it for you. We have the flash memory. Flash memory includes USB flash drive or keys. USB flash drive or keys. We have floppy disk. We have paper tape. We have magnetic tape. We have punch card. We have memory card. These are all examples of storage devices, okay, that falls under secondary storage. Please, whenever we talk about primary storage, we are not talking about storage device. We call it memory because you cannot store data there, okay, but it can be used to hold data while the computer system is working. So storage devices basically refers to secondary storage or auxiliary storage devices. Okay, please, if you have any question, okay, while you're watching this video, you can type it in the comment section. We shall have access to those questions and respond to them in the next class. Okay, now let's go to the last lab of this lecture, the last lab, which is software. Remember, we had talked about, we mentioned hardware and we've treated hardware. Now we want to look at software. So what is software? What is software? Software provides instruction that tells the computer how to create, how to solve a problem, or how to handle a task given to it. That's what we call software. So the software is just like a blood in the human system. It's soft, it runs everywhere. It carries oxygen, food to different parts of the body, okay? Food, nutrients and oxygen and all that to different parts of the body. So software is just soft in its nature, okay? Some people say you cannot touch it. Okay, the best you can do is see it on the screen, and if you attempt to touch it, you are touching the screen, and if you attempt to bring the screen to touch it, it disappears. So that is software for you. So software are just instructions that tells the computer system how to create, how to solve a problem, or how to handle a task given to it. So there are series of instructions that tells the computer system how to solve a problem or how to handle a specific task. Okay. Another name for software is programs. Okay. So some people use it interchangeably. Okay. Programs are created using other software called programming languages. Programs are created using other software called programming languages. If you could remember in the when we're talking about generation of computers, I mentioned something about low-level programming languages and high-level programming languages. Okay, you don't know, so your mind should go there. So for you to be able to develop a software, then you need to use other programs called programming languages that gives you the ability to write instructions in a way the computer system will be able to understand and execute. Now, there are two main types of software. Don't forget this, it's very important. There are two main types of software: the system software and the application software. The system software and the application software. You are going to go through these two types of software so that when you see the software being mentioned, okay, you can have the boldness to ask whether it is a system software or whether it is an application software. Okay. Let's first of all look at system software. Let's look at system software. Are we there? I hope I'm not too fast. Are we there? Okay. System software consists of programs that control or manage the entire operation of computer system and devices. Okay, system software consists of programs that control or manage the entire operation of the computer system and its devices. Okay, that means that system software is for the proper working and the coordination of the operation of the computer system. It is not for us, computer users, to use the system software, though we can benefit from the availability of system software, okay, but we don't use it directly. It is for the system to use it to manage its own affairs, okay, because the system has a lot of things it handles, okay. It has a lot of things it handles while it is working. So it's the system software that helps the computer system to coordinate the activities of different components of the computer system to ensure that all of them work harmoniously. Okay? So that means that system software is responsible for managing a variety of independent hardware components so that they can work seamlessly and harmoniously, so that they can work together seamlessly and harmoniously. Okay? So, for example, let me give you an idea now. If you're working on your computer system and you're doing printing and the printer suddenly runs out of paper, okay, you're going to see a notification window, okay, on your screen telling you that the printer is out of paper. What is bringing that information is the system software, because the system software that monitors the working, the operation of the printer and communicates the status, okay, of its operation to the computer system. Okay, so whenever there's an issue, it's the system software that will flag it up, that will flag it. Oh, that this device is malfunctioning, or this device needs replacement, or this device needs configuration for it to work properly. All that, okay, is handled by the system software, because the system software that manages the operation of the entire computer system and ensures that everything works together seamlessly and harmoniously. Now, there are basically 4 types of system software. Okay. Number 1 is the operating system. Okay. Maybe in due course we shall look at operating system. Operating system is a very powerful system software, okay, that provides an interface between the hardware and application programs, okay, and ensures that different application programs work seamlessly without any issue. Okay, so that's an operating system. So the first software that you're most likely going to install on the computer system, okay, after buying it, is operating system. Some computer system comes with operating system. When you buy it, okay, you can buy it with the type of operating system you want. If you want, let's say Windows, if you want Linux, if you want Unix, if you want Macintosh, okay, you can get the computer system, you know, you can make them come with this operating system. It's just for you to pay the money and they will set it up for you. So operating system is a type of system software. We have the next one is device drivers. Now device drivers are system software that manages interaction between the operating system and installed hardware devices. So we have utility software as another type of system software. Okay, utility software is software for housekeeping operations within the computer system. Okay, like scan disk, like disk cleanup, all these are utility software. Then we talk about translators, the last of the types of system software. Talk about translators. Translators are basically used by programmers. Okay, programmers, these are people who write softwares, and translators help them to convert source code written in high-level languages into machine language that the machine can understand and execute. Okay, we have different type of translators. We have basically we have compilers. Yes, we have compilers. We have interpreters. We have assemblers. These are the three types of translators that are around. Okay, so for high-level programming languages, you can look at compilers, you can look at interpreters. But for low-level language like assembly language, you can look at assemblers. Okay, so these are the different types of system software. Let me go over it again. We have operating system. Examples include Windows, Unix, Macintosh, Linux. The next one is device drivers. The next one is utility software. The last one is translators. Okay, we are done with system software. We quickly look at application software. Application software consists of programs that perform specific information processing activities for the computer end users. Yes. Application software consists of programs that perform specific information processing activities for the computer end users. People who are not computer professionals but consume information generated by the computer system are called end users. Bankers are end users. Engineers are end users. Okay, those people who just use computer system to process data and get output of results are just end users. Okay, so the application software are programs that perform specific information processing activity for the computer end users. Okay, this type of software is used to accomplish specific tasks by end users such as typesetting, graphic design, accounting, etc. Okay, so depending on what you want to do, you can have a specific software, okay, that can help you to do to perform your work or to perform your task. For example, if you want to process word processing, okay, if you want to process word, you can use Microsoft Word. Okay, if you want to if you are a graphic artist and you want to do graphic design, you can use CorelDRAW, you can use Photoshop and all that to edit pictures and all that. Okay, so there are different types of application software, different types. Every area, every occupation, every career line has its own specialized kind of software. Okay, so if you are an engineer, there are softwares that you use that will help you do your work. If you are in the healthcare, there are software you use that will help you do your work. Okay, all these ones are all referred to as application software. Okay, now let's look at kinds of application software. Number one, we have word processor. You have database software. Remember, word processors are used for developing documents. Database software such as Microsoft Access, okay, Oracle, MySQL, MySQL Server, Infomix, Sybase. All these are different types of database software that are basically used for managing large interrelated record of files. Okay, now we have spreadsheet software that are used for analysis of data, arrangements and analysis of data. And spreadsheet software include Lotus 123. Example, Lotus 123. We talked about Microsoft Excel. That one is very common. That one is common. If you have Microsoft Office Suite, most likely you have Microsoft Excel. You have games applications. Games is also application software. Okay, web page browsers too are application software. So these are the common kinds of application software. Please, the list is not exhaustive. Okay, we have different types of application software. So please, you can add to this list. Okay, by yourself. Okay, so that is that under application software. Now let's go to software classification. Software classification. Okay, software classification. They are basically two classifications of softwares. Software are classified under bespoke or user written software, or you can also look at application packages or packaged software. So under software classification, we have bespoke software, otherwise called user written software, and we also have application packages or packaged software. Now, bespoke software is a software that is developed by the end user and tailored to their specific business needs or operating environment. This software is developed by the end user, remember, and is tailored to their specific what? Business needs or operating environment. Okay? You don't buy this type of software from the market. You don't walk into the computer shops and order it off the shelf. No, it's not there. Because this software are software that are created to specific business needs or specific business environment. For example, if you're operating a small shop and you need a software to manage your business, and then your business, you discover that you cannot see a software in the open market that you can use to manage your business operation, you can develop a bespoke software. You can develop user written software. If you are knowledgeable, if you have good expertise, if you have lots of time, you can sit down and develop the software by your time. There's nothing wrong with that. Okay, provided it suits your purpose. Okay, suits your purpose. Then another aspect is that if you cannot write the software, you can contract it out and allow the software to be written, okay, by an external person, maybe a supplier. Okay, you can allow the software to be written by an external supplier. Okay, you can go into a software house, you can meet them, discuss your requirements, they can come to your place of work, take up requirements, specification for the software, and develop the software for you. Okay, and it's even better if you ask the specialist to come in and help you, because from time to time you're going to get support from them. If there's difficulty or if there is an upgrade you need, they will be there to provide the necessary upgrade for your software. Okay, and the only thing is that if you're looking at an external supplier, okay, to write the software for you, the price will going to be high. Okay, most likely the price will be high because the person will have to look at the time it will take to build the software, have to look at the customized component that will create that software that probably cannot be found somewhere else in another type of software. So those things might make the price of the software to go up. Okay, now let's look at application packages. Application packages is a type of application software that consists of a bundle of two or more programs that together address a specific business or industrial needs. Okay, they are usually bought off the shelf from computer shops. Okay, examples include word processing, database, spreadsheet, desktop publishing software. So all these are package application other package software or application packages. Okay, we talk about kinds of software. So we are looking at application packages or package software. We said a lot of things about that one. I wanted to rush to the kinds of software. What you have there on the screen is what you need to know about application packages or packaged software. So let's look at kinds of software. We have these kinds of software. We have public domain software, we have freeware, we have shareware, and we have commercial software. Okay, let's look at kinds of software. Public domain software. Now, public domain software is a software that has no copyright. Now, a copyright is a legal thing. Okay, if you create a software, you need to obtain a copyright for your software. Copyright in the sense that no part of that software or no part of it can be reproduced elsewhere or by another person without your express permission. Okay, so copyright thing is a legal thing. Okay, if you get someone's software and you duplicate it and you sell it without permission from the owner of that software or the person who owns the copyright to that software, then you might likely be sued in court. Yes, you could be sued for infringing on someone's copyright. So that is why every intellectual property like software need to go with copyright. But what we want to talk about now in public domain software is that it has no copyright. No one owns the right to control who make copies of the software. Yes. Okay. Now anybody is free to use or make copies of that software. Okay. Anybody is free to use or make copies of that software. Number 3 point is that the software can be copied, used in other programs or changed by anyone. That means that if you have a source code of that software, okay, you can use it in another program. Okay, you can even change it, okay, and modify it to suit your taste. Modify the code of the software for it to do something different. You can even extract part of that code and put it in a program you're writing to perform a desired function for you, a particular function that you desire. So that is that. So public domain software can be copied, used in other programs or changed by anyone. Now the next one is freeware. Now a freeware software has copyright. It's important, you know. Has copyright. Okay. Someone owns the right to determine who can make copies of the software. Yes. Public domain software has no copyright, but the freeware has copyright. Okay, even though you are free to make copies of the software, okay, but someone owns the right to determine who can make copies of the software. For example, now I can create a freeware, okay, and send it out, but that doesn't mean that because it is a freeware that you have to copy it without seeking the permission of the copyright owner. No, you have to seek the permission of the copyright owner. Okay, so free to use software, okay, free to use and make copies, that is freeware for you, but you need to get permission from the owner of the copyright, okay, from the copyright holder rather. You can only give away the exact copies of the software. You can only give away the exact copies of the software. If I create a software now and I give it out to you, okay, if you are giving it out to another person, okay, then I need to know, I need to give the permission, okay, for another person to use it because I'm the copyright holder. Okay, I need to give out permission. I need to determine who can make copies of my software. Okay, I need to do that. Okay, now even when the software is given out, you don't alter any part of the software. You don't alter any part of the software. So you can only give away the exact copies of the software. Nothing added, nothing changed, nothing altered. Okay, and the last one is you cannot change or use in another program without the copyright holder's permission. You cannot use freeware software in another program, okay, without the copyright holder's permission. And now we look at shareware. Shareware too has copyright. Okay, shareware has copyright. But one thing is this: you can be allowed to use the software before paying for it. Can be allowed to use the software before paying for it. You basically come with a new software that is not popular, that is trying to gain grounds in the market. Okay, so one can actually give out a software as a shareware. Okay, let the people, end users, use the software, test it, and make recommendations or make suggestions as to possible areas of improvement in the software. Okay, then after a while, when the software is of standard, when the software is robust, then you can start paying for using it. Okay, then this software can be a demo. Okay, it can be a demo. It might not have the major features, okay, in it. Okay, can be a demo just for people to have a feel of it, to see it, and to be able to know the possible omissions or the possible additions that could be carried out, okay, on the software. You can set the amount of time you can use the software. So the amount of time one can use the software can be set. Okay, for example, a shareware can be given out, okay, to be used basically within 1 month. After 1 month, your rights to the software will expire and the software might not be active on your system again. It is always done with the mind that you will pay for the software if you like the software. Shareware software is always given in trust that you pay for it if you like the software. Okay, and you are giving it out. You have to give the exact copies of the software, complete copy. You don't hide some part of the software. You don't remove anything. You don't alter anything. You give it out. And the last one is that you cannot change or use in another program without the copyright holder's permission. You cannot change it or use in another program without the copyright holder's permission. So basically, we are looking at kinds of software. Okay, to recap it, And to bring this lesson to an end, we're looking at kinds of software where we consider public domain software which has no copyright. No one holds the right to control or make copies of the software. Next one is freeware, has a copyright, okay, but someone owns the right to determine who make copies of the software. You talk about shareware, has copyright, and you can be allowed to use the software before paying for it. It could be a demo software. It could be there for you to experiment with it. You can use it for a period of 1 month. After that, the software might be deactivated on your system. You will not be able to use it again. You cannot change or use the program without the copyright holder's permission. And the last one is the commercial software. Yes, I didn't look at the commercial software. I think so. So let's look at commercial software before we go. Commercial software has the most restrictive copyright. In the sense that it's for business. You don't copy it anyhow. Okay, if you copy it and somebody sees you, you can be sued to court, and you pay for whatever amount of money you are asked to pay for infringing that copyright law. Commercial software, you have to buy the software before you can use it. Yes, you have to buy it before you can use it. These are standard softwares, okay, that have been tested, that have been proven, that are used by a majority of people, okay. And you can make one copy of the software as a backup. For commercial software, you get it, you can make one copy as backup in case the one you have get bad rather. You can fall back on the backup. Okay. For a commercial software, you do not give it away or sell the backup copy. You do not give it away. That means that you cannot give it away or sell the backup copy. Okay. Now you cannot copy the source code. You cannot even look at the program source code or change anything, okay, that has been programmed into that software, okay, without the copyright holder's permission. In fact, you cannot use part of that software in another software you're trying to develop without seeking the permission of the copyright holder. Okay, so that's commercial software for you. Like Microsoft Word is a commercial software. CorelDRAW is a commercial software. Photoshop is a commercial software. So all these are softwares that have been created and by companies themselves, okay, because they are there to make money. So created and given out for people who want to use their software for one thing or the other. Okay, so remember our kinds of software. Don't forget public domain software, freeware, shareware, and commercial software. So that brings us to the end of this class today. Okay, thank you very much. Remember, we have covered a lot of ground. We started with classification of computers by generation. We looked into classification of computer by purpose, and then we looked at hardware and software. We look at the functional components of the computer system, where we considered input unit, output unit, and the processing unit. Then under the processing unit, we talked about 3 subunits, which was the control unit, arithmetic and logical unit, and the memory unit. Okay, we talked about different types of memory. We talked about the primary memory or the main memory. Okay, and we also said that main memory is divided into 2: the RAM and the ROM. Okay, and we we talked about output devices. We mentioned example of output devices like printer, like monitor, and all that. We also talk about storage devices. Okay, we also said that storage devices are considered as secondary storage or auxiliary storage. Why is it secondary? Because it's a memory that supports the primary memory. So the primary memory is on its own, and the secondary storage is to support the primary memory. Remember that I told that primary memory cannot store a large amount of data. It stores something small that the computer system works with. If you need to store large quantities of data, large amount of data, then you need to use secondary storage. And this secondary storage, your data can be stored and kept outside of the computer system. We mentioned things like optical storage devices, like CD, compact disc, DVD, video versatile disc, and Blu-ray disc. Yes, Blu-ray disc is there. We also talk about hard disk. We talk about floppy disk. We talk about magnetic tape. We talk about flash drive, memory card, and so on and so forth. Okay, and we went into software. We talked about different types of software. We talked about system software and application software. We gave types of system software, which included operating system, utility software, device drivers, and translators. Okay, we give example of some of these software, like operating system. We give example of operating system like Windows, Linux, and Macintosh operating system, and all that. Okay, we talked about application software, and where we talked about software that enables users to achieve a specific purpose. Okay, it could be typing, it could be designing graphics and all that. Okay, and we also talk about classification of software. Software classified into two major headings. The first one is user written programs, or we call them bespoke software, and the other one application packages or packaged software. Application packages are softwares you get off the shelves from computer shops, and are standard softwares. They have large customer base. People use this software, and we are most likely going to get support from a lot of sources. Okay, we also talk about kinds of software. We talk about public domain software, we talk about freeware, we talk about shareware, we talk about commercial software. Okay, commercial software. So this is where we are going to stop in today's class. Please feel free to go over the video again and again. If there's anything you don't understand, and please drop your questions, okay, in the text area of this video, so that I can respond to them appropriately. So thank you very much. I remain Nsangite Asokodo, your lecturer. See you next time. Bye bye.